everybody. Today we're going to do section 4.2, and this is about negative exponents. And I need you to really be careful and listen, because this lesson is a very difficult lesson. There's a lot of common mistakes, and kids have a tough time with it. So let's go over. The questions are basically, what are negative exponents? So let's review kind of what we did from the last lesson and now apply it to negative exponents. Okay, copy all this down. The exponential form of 10 to the third in standard form means 10 times 10 times 10, which is 1,000. 10 squared means 100. 10 to the first power, we talked about, to the first power, you get back the base, which is 10. 10 to the 0, we talked about 0 power, you get 1. So now, you should notice, with each one of these, you're dividing by 10. Okay? 1,000 divided by 10 is 100, divided by 10, so on. If I do 1 divided by 10 to get my next exponent, as these are going down, okay, I would get 1 divided by 10, which is 1/10. Now this is a common error for kids. They see a negative exponent, they think a negative exponent means a negative number. It does not. It just means that the number is becoming a fraction, very small, in between 0 and 1. So now, if I want to the negative second, this means 1/10 divided by 10 is actually 100. And you probably will notice this is the same thing as 1 over 10 to the first. 100 is 1 over 10 squared. 10 to the second power, which is 100. Okay? 10 to the third would be 1 over 10 to the third power, or 1 over 1,000. So each one we're still dividing. If this number is just getting smaller and smaller and smaller and smaller and smaller, we will never reach 0. We'll just keep getting closer and closer and closer to it. So these negative exponents do not mean a negative number. You might want to write that down and put a big star. So negative exponent, in general, if I say a number to the negative n power, that means 1 over that number to the n power. Okay? So by putting it into the denominator, okay, that will get rid of this negative exponent and make it a positive exponent. A, in this case, can never equal 0. You cannot have 0 to a negative power. It will not work. But this works for every other number. Okay. So let's look at some examples. First part, part 1. Write using a positive exponent. They don't want you to evaluate any further. So I need to get rid of this negative 2. Well, I just told you in that rule, all you have to do is to put this in the denominator. This means 1 over 5 to the second power. All we have to do is write using a positive exponent. We do not have to evaluate this. So 1 over 5 squared. Okay, this. To the negative first power. To make that a positive exponent, we just take whatever this is. We don't change this and put it in the denominator. 1 over, keep your negative 2 here, and you just make this positive, 1. Okay, let's try the next one. M to the negative 5th means 1 over m to the 5th power. Okay, negative third exponent, keep your base the same, keep this the same, negative 3, raise it to the third power, positive this time. Okay, so that's the first part. We'll be doing a bunch more of these in class so you can practice making negative exponents positive. Write each fraction, this is part 2, as an expression using a negative exponent other than negative 1. That's important right there, that other than negative 1 part. So let me highlight it for you. Other than negative 1. So we're kind of doing the reverse of what we were just doing. So I need to take this out of the denominator, and I want to make it have a negative exponent. Well, you're doing the reverse. If we bring it back up, it becomes 3 to the negative 4th power, because this means 1 over 3 to the 4th power. So this one's nice and easy. All you have to do is pull it up and make it negative. Same thing here. 9 squared, you bring that up into the numerator, 9 to the negative 2nd power. The next two are where this highlighted part's going to come into play. The reason why it's says other than -1 is because this 8 to the first power, there's really a 1 there that we don't write. You could write 8 to the -1, but they said don't use -1 as your exponent. So we need to think of a way to write 8 so that it has an exponent, a way that I can come up with a number that means 8 with an exponent other than 1. Well, 2 to the third power, because 2 times 2 is 4, times 2 is 8, means 8. So now, if I have the 8 here, now I can bring this up into the numerator. It'll be 2 to the -3rd power. Okay. This one, see if you can write 49 with an exponent other than 1. So you have to think of a way, some number with an exponent that will equal 49. 1 over 7 squared, because 7 times 7 is 49. Now I have an exponent other than 1. 7 to the -2 power. Okay, again, you will practice a ton more of these in class. Part 3, the last part for today, is actually evaluating. You're going to be substituting in and simplifying the whole expression as far as you can go. So a to the -5th, a is 2. So this means 2 to the -5th. You'll notice my little bubble over here that says undo the negative exponent first. You can't do anything with this until you make this a positive exponent. This equals 1 over 2 to the 5th power. Now it's positive. Now I can evaluate 2 to the 5th power, which means 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 over 32. I cannot simplify anything else. That is my answer. Okay. Notice my negative exponent did not make this a negative number. It just made it a fraction. All right, last problem. Plug it in, substitute. A is 2, B is -3 to the -2nd power. Okay. I'm going to undo the negative exponent first. So I take my base, I put it in the denominator. And I put a positive exponent. Now I do 2 times -3 is -6 raised to the 2nd power. -6 to the 2nd power. 1 over -6 times -6 is positive 36. Okay, again, we'll practice more in class. If you need to, go back, rewind, listen to this lesson again, because it is a difficult lesson. Have a good night.